So I'm going to take over again and talk about my second topic, which is about supporting multiple backends. We are now supporting an Access backend and a SQL Server backend, and the customer can choose which one they want. But this is also relevant if you're just thinking about migrating from an Access backend to a SQL backend. Everything that I'm going to be talking about applies to that scenario just as much. So the history of this is that indeed 4 or 5 years ago, the market forces were such that, having a SQL backend was really important for Dizzy, and that's around the time that I got involved with the project. And as I spoke about before, we really felt that we want to update the database design first before we go to SQL Server, have it be as clean as possible. Critical, and this will be, common sense, but you really have to understand the platform that you are targeting. This is not a matter of relinking the backend to SQL Server and be done with it. That would be half a day, but as it stands, there's a lot more to it than that. Relinking the backend may work for Northwind, but it doesn't work for a Dizzy size application. Another thing that we did from the beginning was we wanted to write abstract code as much as possible, kind of wrapper functions that you can call that themselves would know how to do things with Access or with SQL Server. And as the developer, you just call those functions. We call, as developers, abstract functions all the time. Think about document open form. What happens when you call that? There's an enormous amount of code in Access to make sure that that form actually appears on the screen. We don't have to worry about it. That's a black box. We pass in 5 parameters and we go. We like to write abstract code like that as well. Code that we write once, test, and it's sitting there. It's good to go. It makes us less dependent on, over the years, as Microsoft is perhaps leaning the DAO way or the ADO way, or coming up with something else. If such a thing were to happen, we have to make changes in only a few places and not all the way around, across the application. This, of course, increases the robustness of our application as well. We're relying on fewer functions that are well tested. And as we are releasing new versions, Dizzy is on an annual cadence, if not more frequent. It also requires less testing. When we call those functions, we know that they're good to go. Here are some of those functions. The bold ones are ones that we'll be touching on a little bit later. Here's another example that I'll just touch on very briefly. Run action query. We all understand current db.execute, MySQL statement, comma, db fail on error. Well, there's something similar you can do for SQL Server. And if you always call this function rather than whatever the Access or SQL equivalent is, then of course you increase the robustness and the level of abstraction in your application. So these are all good things. You'll see that many of these functions are related to manipulating the database, because that is indeed what happens a lot with Dizzy. As the market for medical applications changes, Dizzy needs to adjust to that as new features are being rolled out. So let's take a look at kind of one of the ones that give you a good skeleton of what they would look like. Change field data type. We want to change from a text 50 to a text 80, or from an integer to a long integer, or from a Boolean to an integer, whatever. We use a function pattern similar to this. We have a select case for a backend type that has already been established as a global variable. So it's either accessDB, not access because that's a reserved word. So it's either accessDB or it's SQL Server. And if accessDB, we can change the field data type very simply by calling alter table, alter column. Let's say get field data type might return something like text. 50, and then not null. And then we run an action query that executes the SQL statement, and life is good. That's all you need to do for access. And that's kind of the original code in Dizzy until we got to case SQL Server, where you have to do a little bit more work. But again, you have to do it only in this one place. So we get a SQL statement. This is kind of pseudo code. It's a fairly hefty union query that I'll show a little bit later, a little bit of. And then we run a pass-through query that gets us that set of constraints, they're called in SQL Server, check constraints and default constraints that we need to drop, because you cannot change the data type of a field that has a check constraint or a default constraint on it. So we just call drop constraint, no big deal. And then we change the data type using a SQL statement very similar to the one in Access, just that you need to put your schema name DBO dot table name in here. Since Dizzy only uses DBO, we can hard code that. And if this was a library to be used by everyone, we would probably do it a little bit different. We call that same get field data type, null or not null, and we call that exact same run action query. So that's really nice reuse of this high level abstract code. And then, of course, since we had dropped them, we need to put all the constraints back. Fortunately, that record set that we had gotten from the database about the list of all the constraints is a disconnected record set. So we can just move first, loop over them and say alter table, add constraint. That's how you do it for check constraints. And for default constraints, there's a very similar SQL statement that I just left out for brevity. And again, we're calling run action query to actually apply that statement to the database. As I already hinted at, data types are different between SQL Server and Access. And so we have a function where you can type in or pass in your data type, and it comes back with what that should be called. Is it text or nvarchar? Is it memo or ntext, etc.? Is it single or real? Very, very simple. But this is the kind of wrapper functions that you need to create when you support multiple backends. Another thing you run into is, are we using single quotes or double quotes? Are we using hash marks or single quotes for our date values? And so further wrapper functions to return the correctly decorated values if you have literal values in your SQL statement. I talked about knowing the platform. So here's a good example of that. Certainly we could have called delete star from table name, which is actually something we do in this application. It's unusual for a business productivity application, I guess, but in Dizzy it does happen. We loaded several tables with government data or insurance company data about medications, or I'm not actually quite sure what all it is about. And it changes on an annual basis. So we have to drop everything and then load the new data for the new year. And so delete star would certainly have worked against SQL Server. The ODBC driver would have translated that and taken out the asterisks, and SQL Server is happy. But we have a better statement, truncate table, which runs much faster, because it is actually not a logged operation. It's a non-logged operation. And so we said, okay, well, if we call delete all records, we're just going to use truncate table. I already mentioned that sometimes supporting a new backend is more work. If you want to drop a field, you cannot do that. In Access, it just works. Delete the field, done. In SQL Server, you first have to delete the constraints. There's also a difference in how you get information, metadata information about the system. And in Access, you would use your MSys objects and MSys tables, perhaps, and certainly your DAO object collections. You know, table dev dot fields x dot and so on. But in SQL Server, you have a rich collection of catalog views that give you dozens and dozens of views with very high detailed information. And so you'll see that in a second how we take advantage of that. But you have to know that they're there and how to find essentially equivalent information or even more powerful information using this new backend. Here's an example. If we call has index to test whether or not a table has a particular index, in this case, we want a duplicate index on customer ID plus order date. You know, we do things like for each index on this table, indexes collection, for each field in that index, let's see if it's the customer ID and the order date. In SQL Server, we would do the exact same thing, but using a query across 4 of those system catalogs. So it's good to know that these are there, and you should really use those to your advantage. As you can see from the size of the thumb, there are many, many available fields in some of these objects, some of these virtual tables, including stuff that hopefully you'll never have to touch. Partition ordinal, what the heck is that? I have no idea. Transactions is another very interesting area. Of course, we want to use transactions because we have to be concerned about the integrity of our database. So in Access, we have a very high level, again, one of those abstract functions, delete parent child. We don't have a function that says delete order. But the effect is the same. Delete parent child, you pass in a bunch of arguments, and we go ahead and say, okay, you're talking about this table, you're talking about this field, you're talking about this value, and let's go ahead and do that. Delete the children, delete the parent, and we do that inside of a transaction. If you run this against the SQL backend, you may have locking issues. Remember that this is running. It has the patient form open. You've seen the patient form. It has a dozen tabs. There's a lot going on in this application. And so sometimes functions like this don't work. And what we have found is that if we use a pass-through query and run this transaction on the back end, it does actually succeed more often than not. And so this is the way we decided to go do it. Very simple, really, to create a transaction, delete your child records. If it fails, roll it back. Delete your parent record. If it fails, roll it back and commit. So again, you have to write this only once. You're doing this for a very high level function. If this works once, I mean, the only time we had to go back here perhaps is if we had a self join or something like that, where the order table and the order details table was actually the same table name, and things might get a little bit more complicated. But otherwise, this works really well. So that's what I want you to take away from this, is whether you support multiple backends or are thinking about upsizing to SQL Server, write as much abstract code as possible. So you're less dependent on data access methods, you improve the quality of your application, and you have less testing to do. It's just simpler to write code. Some of these queries are incredibly complex, and so wrapping them in some code that gets written once and tested well is really the way to do it. And here are some of the things that we had to struggle with as we were moving. Several others are probably in your path, but if you know your platforms well, I'm sure you can get past it.